When it comes to rate of change, it's more like you doing partial differentiation. So what that means is that you need to be a master of your partial differentiation before you dive into this topic, this subtopic under differentiation. Now, let's consider this. Let's say you have, I believe you can differentiate. Say you are given a function y is equals to 2x cubed. From here, your derivative becomes what? Dy dx, right? You are differentiating y with respect to x, meaning dy over dx is equals to 6x squared. Now, from here, what it means is that y is a function of x, right? In a case whereby you have y is a function of p, let's define y to be this: 2p cubed plus 4p. Same idea, find the derivative, right? Meaning dy dp. In this case, y is a function of p. Then your dy dp becomes, this will be what? 6p squared plus 4. Now, but let's look at another concept. This is just for differentiation. This is total differentiation. In this case, you have a dependent variable and an independent variable. Now, your dependent variable in this case is what? Y. And the independent variable is what? X. Meaning x is depending on what? Y. Are you getting the idea? X is depending on y. In other words, you can say that y is a function of x. But now let's consider this. Let's talk about partial differentiation. When you want to, since I said you'll be given a question under rate of change, how do you work it out? The idea is simple, and you are using what we call partial differentiation. Now, let's see what partial differentiation means. Here's how it works. Let's say that f, in this case, y is given to be a function of x, right? Meaning, we'll be given y is equals to function of x and z. Not necessarily x and z. It might vary. It varies. Let's say this is one. Call this one. Let's say 2. Y is a function of p and t. This man here is still the same thing as this. Why? Because check case 1. Case 1, y is given to be a function of two variables, meaning x and z, right? Now check case 2. Y is also given to be a what? Two function, but in this case they are what? P and t. So what you are saying in essence is that when you have a dependent variable express more than two functions, then you use the idea of partial differentiation. You know, from here, you have something like this, you can differentiate. Of course, you can differentiate. But your derivative in this case, you have two derivatives. Are you getting the idea? Implementing what we did here, from here, we said, given that y is a function of x, we now take this example, right? Meaning y is equals to 2x cubed. Find the derivative. What do you have? Dy dx is equals to what? 6x squared. Now, same idea. We are giving this guy here. Check this guy here. Check case 1, or you say equation 1. Check equation 1, and let me call this equation 2. Check equation 1 and equation 2. What is the difference between equation 1 and equation 2? This one has one variable, right? This one has what? Two variables. This having two variables doesn't mean you can't find the derivative. You'll be able to find the derivative, but the idea will just change. And that's what we call partial differentiation. Are you getting it? Now, from here, what it means is that your differentiation, sorry, what it means is that your derivative, in this case, you have dy over dx and dy over dz. Agreed? Yes or no? From here, I can differentiate y with respect to x. I have my first derivative. From this equation 1, this same equation, I can differentiate y with respect to z. I have my second derivative. But in this case, there's a way to symbolize partial derivative. Are you getting me? There's a way we symbolize partial derivative, like the denotation is different. So the difference is that to be specific, to show your examiner that you know what you are doing, or the concept is that since it is a partial derivative, then this is how you represent a partial derivative: delta, something like this, dy over dx is equal and dy over dz. What is the difference between this? Call this one and call this two. What is the difference between one and two? The difference is the way we denote it, right? This one, what this one means is that you are doing normal differentiation. You are doing what? Normal differentiation. But whenever you see this in your textbook or anywhere, you should know that this is referring to what? Partial differentiation. So this is what differentiates between normal differentiation and partial differentiation. And it is not just called normal differentiation, it is called total derivative. Total derivative. Now, let's see how it works. Given that y is equals to 2x squared, given that y is equals to 2x squared z raised power 3 plus 4z raised power 4x plus 2z. What does this equation? This is an equation given to us. Of course, you are going to differentiate, right? You are going to what? Differentiate. You apply the idea of differentiation. But observe this equation. You are given that y is a function of two variables, is it not? What are the variables in this case? X and y. That is, y is equals to function of what? X and z. Rather, z, not y. Meaning, y is given to be a function of what? X and z. How do you now solve? You apply the idea of partial derivative. Now, this is how it works. From here, when you are differentiating with respect to x, you consider z being a constant. Are you getting it? I'm differentiating with x. You know, from our analysis here, we said from this, I'm going to have two derivatives. The first one is what? The derivative of y with respect to x becomes my what? First derivative. Abi? The second one is what? The derivative of y with respect to y becomes my what? Second derivative. Now, let's perform the first one. From here, we are differentiating y with respect to x equals question mark. Also expected, I will have the derivative of y with respect to what? Z question mark. Are you getting me? Now let's solve. I said earlier that to solve for this guy first, you know, this one now, we are differentiating y with respect to x. Any any z variable will be considered as what? Constant. Meaning, okay, this is it. Let's say you have y is equals to 2z raised to power 4. Sorry, 2x squared z raised to power 4. Expected, I will differentiate with respect to x and with respect to what? Z. Now let's differentiate for the first one. Dy over dx, and not just dy over dx. I believe you know what this means. Partial derivative of y with respect to x. Now from here, you really want to solve this using the idea of normal differentiation. Now observe, your x function is what here? Your x function. You know, from here you have x and z. You observe that your x function is x raised to power 2. Are you getting me? Similarly, your z function is what? Z raised to power 4. Now, since you are differentiating y with respect to x, your interest should be the x function. Are you getting me? Your interest should be the what? X function. Now, the x function in this case is what? X squared. Differentiate x squared. What do you have? Differentiate x squared using normal differentiation. What do you have? 2x. It means that equals to 2x all into bracket. Consider the rest as what? Constant. By constant, repeat it. All into bracket. These two, this is it. Times what? Z raised to power 4. Open up. Distribute. What do you have? You have 4x z raised to power 4. And this is your partial derivative of y with respect to x. Now let's apply the same idea to get the partial derivative of y with respect to z. It becomes what? That will be what? Observe. Your first thing first. Since you are differentiating y with respect to x, your interest should be what? X. That's what we did here. Then we note that the function of x here is what? X squared. By the time you differentiate x squared using normal differentiation, you got 2x. 2x all into bracket. Repeat this guy. This 2, this is it. This dot means multiplication. Dot z raised to power 4. Then distribute this algebra. then you have this. Are you getting it? Now I want to differentiate y with respect to z. Your first task should be what? Identify the z function. Now check, where is the z function here? Z raised to power 4. Using the idea of normal differentiation, differentiate z raised to power 4. What do you have? 4z cube, meaning 4z cube all into brackets. Repeat what you have here, 2x squared. Now distribute this, multiply. What do you have? What do you have? Multiply this. 8x squared z cube, and that's it. That's what we mean by partial differentiation. Partial differentiation. Now with this idea, we will be able to solve this equation. Yes or no? With this idea, we will be able to solve this. Considering this guy separately, considering this one too separately, and considering this one. So that's how it works. That's how partial differentiation works. By the time you have the idea of partial differentiation, you will have problem under rate of change. Let's solve this question. Say you are given this question, you have to find the derivative. This question, you have this question. The question says that find the derivative without you being told. Like, you know, the question just come and say find derivative. What type of derivative are you expecting? Partial derivative. The question is why? Because the dependent, the function itself is defined to be two variable, and that's the concept. Now from here, let's apply this. It becomes, let's solve for okay. Now let me say this. What if, because I'm having two variables, my derivative becomes 2. What if I'm having 3 variables? The derivative will be what? 3. So that's the idea. What if I'm having 5 variables? The derivative will be what? 5. So take note of that. Now let's solve this guy here. The first derivative in this case, I'm differentiating y with respect to x. Now let's solve. What do we have? Let's consider this guy here first. Let's take it gradually. Let's consider this. That's what? I'm differentiating y with respect to x. Your interest should be what? X. Now observe. What is the function of x? X squared. Differentiate x squared using normal differentiation. What do you have? 2x. No, let's take it step by step. Differentiate x squared with normal differentiation. What do you have? 2x. You are saying that 2x, take the rest as constant. 2x all into bracket 2z cube. You are done with this guy here. Right? Moving on. What do you have? 4z. 4z. I need a chorus answer.
4z raised to power 4x.
Why? You forgot your differentiation. In differentiation, what if I give you something like this? Your first task is what? I said it before. Recall. What was your first task? Now we are working with this guy here. What should be my first thing? What should be my first step?
Find the function of
the function of the, and in this case it is what? You are differentiating with respect to what? X. You differentiating with respect to x. Go to that in this case, go to that term. This is the term here, right? Now identify what is the function of x here. X raised to power 1. Now relate x raised to power 1 to differentiation. Meaning if y is given to be x raised to power 1 in differentiation, what is your dy dx? 1. Because from here there's an invisible one here. 1 times 1 all into brackets x raised to power 1 minus 1. This is what? 1 times x raised to power 0. Anything raised to power 0 is what? 1. 1 times 1 is what? 1. So don't be confused. Still the same idea. Alright, from here you've gotten the derivative with respect to x to be 1. That is plus 1 all into bracket 4z raised to power 4. Any question on that? Moving on. What do you have? This should be what there? 0. It should be what? 0. And the question is why? Because when you have something like this, okay, let me hear your opinion. Because what? Because there is no x. Which implies that given y is equals to f of x, right? Expected you have to find the derivative, but the expected derivative in this case is what? dy over dx, right? Now using this same function, I'm now telling you that find dy over dp. The answer to this will be what? 0. And that's what we just did here. Meaning that you can just see that y is equals to 2z. As you are differentiating with respect to x, your interest should be what? X. Indirectly, you are looking for what? Dy over dx. And dy over dx will be what here? 0. So that's what they did. So from here, you have what? Plus 0. Any question on that? You really want to solve to tell me the derivative of dy dz. Alright, let's open up our bracket. Meaning partial derivative of y with the partial derivative of x is equals to what? 4x z cube plus 4z raised to power 4, and you are done. From here, you can even factorize. Yeah, let's factorize. That becomes what? 4z cube all into bracket x plus z. So this is your derivative. This is your first derivative as far as this equation is concerned. Now next up, let's find the partial derivative of y with respect to z. Using the same idea, nothing is changing. You know, there's one beautiful thing about engineering generally, which I've figured out so far. Because whenever you are given a question, by the time you understand a particular principle for a topic, that principle remains constant. Nothing is changing. Let's say for instance now, you guys are doing centroid in applied mechanics. You observe that given a question like this under centroid, find the both x and the y or whatever. Let's say you have this now. Find the centroid, the y axis, and find the x axis. And let's say you have this one. Same thing, find this. Find this one too. I believe you know what this means. The centroid at the y axis, the centroid at the x axis. Now check these two figures. Are they the same? But with the principle change? No. So what I'm saying is that as far as you know that particular principle governing a particular topic, the principle remains constant. And that's the beauty of engineering that me have figured out. You get? So what I'm trying to say in essence is that as far as you understand this idea, then the partial derivative of y with respect to z remains the same, using the same concept. Any questions so far? Now let's solve. You guys really want to tell me what the partial derivative of y with respect to x is. So I want an interactive class. That would be what? Meaning partial derivative of y with respect to z is equals to what? Alright, what do you say? Are we agreeing with that? Oh, for sake of, so it won't confuse you. Just, although if you do it anyway, you still get the same thing. But I would advise your interest, since you are differentiating y with respect to z rather, focus on the function of z. Leave every other thing, take it as constant. Well, what I'm saying, if you consider 2 for z and you consider 2 for x, at the end you get the same thing, right? But so that for easier understanding, just focus on your z function alone, not concentrating on the scalars that you have there. If it is 2, 5, whatever. Alright, now that would be what? That would be, yeah, round it up. What do you have? Just tell me. You already understand. So I want to believe you already understand now. Just tell me the figure direct. 6x squared z squared, okay? Plus 16 what? 16x z cube. Arrange your algebra alphabetically. Yeah, xz, x should come before z. You get? From here, by the time you differentiate this one, that's 4z cube, right? This is it. 4z cube all into bracket 4 times x. So this time this is what? 16z cube x. but always arrange orderly. That will be 16x z cube. Yeah. Now from here, what do you have? 16x z cube. Is that plus 2? Plus 2. And that's, you are done. You found the partial derivative of y with respect to x and the partial derivative of y with respect to z as far as this question is concerned. Now, if you can factorize, good. But if not, you can leave it. So let's factorize, since we can factorize from here. What can we factorize?
2.
Okay, we can factorize 2. Or better still, let's do it this way. 2x z square all into bracket x z, right, plus 8z plus 2. Any question on that? This guy here already factorized this instead of factorizing everything. So let's work it out like this. This time, this is what? Yeah, that's correct. 3xz. Yeah, 3xz. So this is how partial derivative work, partial differentiation. This is how it works. Now, I want to see the level in which you understand differentiation. Let's find the partial derivative of this function. Let's say y is equals to tan all into bracket x square minus y square. From here, given this question, find the derivative. Okay, first thing first, what type of differentiation is this? Is it total differentiation or partial differentiation? Why is it partial differentiation? It is partial differentiation because in this case, y is given to be a function of x and, this is z. Z is given to be a function of x and y. Meaning, you already know that you get two derivatives. The first one being what? The z, not just the z, partial derivative of z with respect to x. That's the first one. Partial derivative of z with respect to x, and the partial derivative of z with respect to y. Now let's work the first one out. Now, what type of, in differentiation, what this means is that you just recall your differentiation. Though looking at this like this, you should be able to tell the answer. That's if you are good at differentiation. But now, I want to ask you this. In differentiation class, what type of techniques can you relate this to? Chain rule, exactly. You can relate this to what? Chain rule. So meaning you are going to perform chain rule here. And by chain rule, what does it mean? How do you identify if a given equation is under chain rule? It is very simple. When you have an expression, by expression, you know what it means. Let's say, this is different from ax plus b. Is different from ax plus b equals 0, right? This one here is called what? Expression. Why this one is called an equation? Why is this an equation? Because of the equality sign. Are you getting me? Now, to identify your under chain rule, product rule, though maybe I will explain that later, but for the sake of this question, let me just explain chain rule. To identify, you have to use chain rule. Is when you have an expression, the expression, it can be either positive or negative in a bracket having a power. So you have to use what? Chain rule. Hope we get that clear. When you have an expression, the expression, it can be what? Positive or negative. You have them in an enclosed bracket, and that same expression is having a power. Meaning, this guy here, let's say y is equals to ax plus b, and y is equals to all into bracket ax plus b raised to power n. Call this one, call this one, call this 2. Which one do you think it will fall under chain rule? 2. Why? Because the difference between this one and this one is the power and the bracket. Now let's say you have 3. Let's say y is equals to ax raised to power n plus b raised to power n, then you have 3. Same question. Which one do you think it will fall under 3? Under chain rule? 2. Same 2. Why? Because this guy here, this expression, it is inside an enclosed bracket and it is having what? A power. Unlike equation 3, the power is affecting it separately. So the idea that we are going to apply here, it will be different from equation 3 and it will be different from what? Equation 1. Looking at this question, it is chain rule that we are going to apply. Why? Because this bracket, you can relate it to equation 2. Yes or no? Yes or no?
Yes.
You can relate this equation 2. This given question rather, you can relate it to equation 2. Because x square minus y square, it is an expression. The power here, n means power. The power here is what? 1. Are you getting it? So, seeing this question, you have to use chain rule. So, your ability, whenever you are given a question, your ability to define, to know the techniques, to identify the techniques to use is very important. Be it chain rule, be it product rule, or quotient rule. And the idea of product rule, as the name implies, product, quotient, division. Are you getting me? Now, moving on, what do we have? And because your formula, since we've identified that we are using chain rule, your formula for chain rule is what? dy over dx is equals to dy over du multiplied by du over dx. You know, recall from algebra, we said, okay, let me do this before saying that. Let's say you have dm over dx is equals to dm, sorry, let me use that same dy. Dy over dx is equals to dy over dm multiplied by dm over dx. Now check, let's call this one case 1 and call this one case 2. Check case 1 and case 2. Do you have any difference? I'm telling you that case 1 now, it is the formula for chain rule. Case 2, also the formula for chain rule. Now the question is, are they the same?
Yes.
Why do you think they are the same? Let me start from there. Why do you think they are the same?
But they are not using chain.
Yeah, they are both using chain rule, but why do you think they are the same? It's still the same techniques, right? You're actually on point. But what I want to hear is that, okay, all right. The u cancel the u for case 1. Case 2, the m cancel the m, and that's it. Meaning that your interest or your priority as far as chain rule is concerned, irrespective of the variable you are using to represent your function, your left hand side must be what? Equals to the right hand side. That is, chain rule does not have a particular formula, but in most textbook you see case 1 here. Yes or no? Why? We are saying this because in that textbook they use u to represent their function. They are using it as reference. Are you getting me? So what I'm trying to say is that you can, when you are saying, you know, definitely you said let u to be something, let u to be this, right? Yes or no? In your chain rule you do that, let u to be this. You might not use u, you might use let a to be this. At the end you get the same thing. What I'm trying to say in essence is that your priority should be that the left hand side must be what? Equals to the right hand side. And truly, by the time you check case 1, this can cancel this, right? This can cancel this. Then you have the left hand side equals to the right hand side. So, and that's chain rule for you. All right, let's solve this question. Now let's solve this question. Your assumption here, when you are saying, you know, we've seen how it works now. Not necessarily we should use you to represent. So depending on you. Now from here, your first task, represent this closed bracket. So what should be the variable?
Yes.
X. No, you can't use X here.
Yes.
You mean X, the other X.
Yes.
Let's use P instead. Let P equals to x squared minus y squared. From here, we want to get partial derivative of the z over the x. You know, since you've said let P to be this was the given question, right? Then this given question can be written as z is equals to tan P, right? Meaning anywhere you see P, Anywhere I see x square minus y square in the initial equation, what do you have here? P. Now from here, what it means is that you are working with this and you are working with this to get your partial derivative of z with respect to what? X. Similarly, you are working with this and this to get your partial derivative of z with respect to y. But before then, let's write our formula out. For the first one, the formula for partial derivative of z with respect to x will be what? Since we've used p now, the formula becomes what? Relate what we have initially. Where you have u, put p there. Since we are using p now, that one will be what? The z over the p times the p over not just the z, sorry, not just the x. You read it as partial derivative of z with respect to p multiplied by the partial derivative of p respect to partial derivative of z. Since we are under what? Partial derivative. Since you are under partial differentiation, you telling me the z, you are still referencing to total differentiation, and the idea in total differentiation and partial differentiation, they are different. Yes or no? So take note of that. Now from here, meaning to get the first derivative, you need this guy here, you need this guy here. Yes or no? Are you getting me? To get this derivative, you need this ratio and you need this one too, right? Now we will come back to this. Let's write the formula for the second derivative too. Partial derivative of z with respect to y. That will be what? Partial derivative of z with respect to p. Okay. Now, what I want you to do for me is that check this first one, check this first equation, and check this first equation and check this second equation. You know the unknowns here, they are the z over the p times the p over the z and so on. Now check this equation. Is there any way we can get the unknowns? Hope you get my message. These are the unknowns that we need. With these two guys, can I get these unknowns? Yes. How? By the time you differentiate. Are you hearing me? By the time you differentiate, you get this unknown. By the time you differentiate the first unknown here, by the time you differentiate z with respect to p, you get the value. For this second one here, by the time you differentiate p with respect to x, you get the value. Are you getting me? Similarly to this. Now let's obtain the unknowns. Derivative of z with respect to p. What do you call it? Sec square p. Then the partial derivative of p with respect to x. That's what? That's 2x. Then for the second one, the partial derivative of z with respect to p. Sec square p. Then the partial derivative of p with respect to y. So you can compute the value of this unknown into the first derivative and the second derivative. So for the first one, partial derivative of z with respect to x is equals to, what's the value of the z over the p here? Sec square p dot, that's what? 2x. Meaning 2x sec square, and what's your p?
X square minus y.
Open bracket, x square minus y square. Any question on that? Similarly, the z, partial derivative of z with respect to y, that's what? What's this? Okay, same sec square p, right? Dot 2. Now telling me 2y is wrong. Negative 2y. Hope you observe that. Negative 2y. Negative 2y. So this is what? Negative 2y sec square, all into brackets. Substitute the value of your p. X square minus y square. And you are done with this question. From here now, this was the given question. You found the partial derivative with respect to x and the partial derivative with respect to y. Now let's take down our first example on the rate of change. Let's take